Feature binning. Just in previous lecture, we have seen the how to use the indicator variables, means binary type of variables, how we will use to construct some real valued features to a binary feature. So we have seen this thing, but this is the some extension. This is the same kind of thing, but it has little bit extension of the features of the uh, features that we have used, means the indicator variable that we have used in just previous. So it is the simple extensions. If you think like it is an extension of it is the extension to the indicator variable. Okay, so let's try to understand through this an example. Through an example, let's try to understand it. The same examples also we have taken here to discuss these discussions. Okay, the examples that we have taken, the height, the same examples. So suppose we have some height data like these are the these are the plots of the some height data. We are interested to binning this thing. Binning this height means if this height less than this, we have categorized this as a 1. If this is thing like here, we have categorized this like 2 in this range. If it is 4, like in this range, we will categorize this 3, and otherwise it is 4. In this type, we want to categorize. Suppose this range is like 120 centimeter. Let this each range is 150 centimeter. This edge is like 180 centimeter. Let this is the range. So how we will doing this? Simple, using the if else conditions. We can use this thing. If our height is less than 120 centimeter, then we return 1. Then we return the category 1. If same thing, if the height is greater than is equals to 120 centimeter and this height is less than 150 centimeter, then we give the output, then we return 2. Similarly for the rest ones, if this height is greater than is equals to 150 centimeter and the height is less than how much? I've taken 180 centimeter. Then we give the return P, and else we give the output 4. This is the simple programmatical point of view we can easily do in this job. So, but these things actually depends on the problem to problem, that what is our actually problem. Based on this problem, we have to categorize these things. Okay, this is the simple real value data. We can easily convert this real value data to a categorical data. We can easily. It is the problem specific. Simple, it is a problem specific. Now let's try to do these things automatically through a task. So suppose let the task that we have. Task is predict the gender based on some features. This is our task. We have to predict the gender given the based on the features, based on the category features, or you can think like category based on these features. These features is height, weight, hair length, and eye color. Based on these 3 features, height, weight, hair length, and eye color. Based on these features, we have to predict what will be the gender or not. So first, the data set. Let look like the data set first. So the data set will be look like this type. Look like this type. So first, it will first column is responsible for height. Second column is responsible for weight. Third column is responsible for hair length. Fourth column is responsible for eye color. And the last column is what will be the gender. What will be the gender? These things. And these things are actually called the X-eyes. These things are actually called the X-eyes. And these things are actually called the Y-eyes. These things actually called the Y-eyes. So Y-eye value will be 0 or 1. You can think it will look like this. If it is 1, then we can think like it is a male. If it is 0, then we can think like it is a female. This kind of value. So now on this dataset, we have only based on the height features how to predict the gender. How are we doing this job? So based on the height, we have interest to sample the binding these height features. That we have to interest. We have to binding these height features. That we are interested only based on this thing. Now let's see how we will doing this. So, and this is the most interesting tasks here. If we are doing these tasks, then for each category we can easily do. For weight, for hair length. So let's try to understand this for this height, how we will doing this job. So the interesting tasks, interesting challenge, or you can think. Interesting challenge, you can think like. How we will binding the age using this data. Using this data means, so interesting challenge is how will binding of age using the data. So here data will be what? Here data will be our category and the features. Means here features is age. Category and features. Feature. This will be the sample data we have. Using on this data we have to binding the height. Here age is our features. Here age is our features. Here age is our features. So that's the actually main interesting. Let's see how we'll doing these things. So the solutions of it. Solutions it will be look like that. So data set, it will be better if we write these things. So the data sets will be look like this type. This type. So here in one column it will be age, here another column it will be the gender. So gender will be 0 or 1. If 0, then male, otherwise female. 0, 1, look like this. Here it will be some real valued features here. This is some real value. Now we have to somehow binding this real value to data. Okay, how we are doing this job? So doing this, we have applied the simple binary tree on. Already we have learned we did simple apply the decision tree. With simple features we have and single output. Here actually you can think like this, it is a xi and this is a yi. By simple decision tree we have applied here. Decision tree, simple decision tree we can apply. If we apply here, then we will find some beautiful decision tree. And its condition here is the threshold value that you have manually doing this job. It's by using this simple decision tree, it will be automatically detects what will be the threshold value. it will automatically detect based on this output and on this thing. Okay, so let's see. So let's suppose if suppose let's after applying this decision tree algorithms on this data, will got beautiful like this. If height is 130 centimeter, then we will got that our yi is equals to 0. Okay, if no, if this thing is yes, if no, then we will apply onto it another conditions, another thresholds value. If age less than equals to, let's say, 180 centimeter, then we got somehow here have another yes or no. If no, then we will consider it is the return the output yi is equals to 1. Otherwise, if yes, then we have apply here another threshold condition 150. Look like this type. Just I am taking here as an example. Then otherwise it is yes, then we get the output yi is equals to like 0. This beautiful type of structures we can got by simple using this. So just using the simple decision tree concept on this data, on these data sets, we can easily got the threshold value. What will be that? Here I am not doing this thing manually. It's the main beauty. So make some sense here. Just using these things. Just see it. Here these things are here this age here. Here now here it makes some sense to use YIs to perform the binary, to perform binding on age. Okay, it makes sense to use YIs to binary on age. Hence, by simple using this design, it gives some sense based on this output, based on this output result. It gives some sense. So the decision tree that we got here, if you write these things as a programmatical point, we can easily write these things as a programmatical programming point of view. Just see it, how we're doing this thing, how we're doing this thing. If you write this decision tree in a programmable point of view, so we can write it like if age is less than 130 centimeter, then we return 1. If sorry, return 0. Suppose let it will be usable. I am using here it is 1. This conditions is 1, and these conditions happen, this condition is 2. If these things happen, these conditions is somehow late. It will be better if I write it. If yes, if no. 1. Okay, here these things is, here these things is 3. Sorry, 3 and 4. This is the 4 output. If this thing happens, suppose that if age less than 130 centimeter, then if this thing is yes, then we give the output return what? Return 1. In this thing we print out. If our age means greater than is equals to 130 centimeter, and if age means it's less than 180 centimeter, if yes means age less than 150 centimeter, 150 centimeter. If this thing's 50 centimeters, means it obviously also 180 centimeter. It's trivial. So if this less than 150 centimeter, if this thing's 150 centimeter, then we return 2. If age is no means I am talking about this thing, it's greater than is equals to 150 centimeter, and it less than obviously 180 centimeter. If this thing happen, then we return 3. And last conditions, it will be if Age is greater than 180 centimeter, else means I'm talking about if, or greater than equals to 180 centimeter, then we give the return 4. Okay, this 4 kind of, we can easily build these things by using this simple decision tree technique. I think you got the point. If you forgot, I will remember you how we will construct these things in the chapter of decision tree. Already we have discussed how we'll build this, how we'll consider, how we'll find this threshold value for age. This is actually taking the decisions. How we'll find this threshold value? How will, based on the what? Based on the informations gain. If you forgot me, I strongly recommend you, please go the decision tree chapter and please revisit this. Based on the information gain. In short, we will write it IG. Okay, already we have seen this thing. So the binning of the data, binning of real valued features using simple the data set. So the binned real valued features using the data. Data means here I am talking about the features and the YIs. And YIs. Data, using the data. Okay, being the real valued features using the data by applying simple decision tree. Simple decision tree. By simple using the decision tree, we can find the what kind will be the bint of that particular real value. Okay. So when we will start the case study, when we will go to our case study, or if you are a Kaggle competitor, if you just participate on the Kaggle competitions, or when we have discussed the case study, then we will see its applications, how much it is applications, or when we do the case study, then we will see. So by simple using the decision tree, so how we will build the features by simple, we have used the decision tree based feature. Okay, we'll see these things when we discuss the study in more details, in more applicable point. I think from these discussions you got the intuitions how we will use this is the simple decision tree technique to find the real valued features, to build the real valued features to a features binning. Okay, how we'll find this threshold value, what will be the best threshold value based on the output. Okay, I think you will got the idea how these things actually work.